Hi everybody! So, we made this machine and it seems to have caused quite a bit of a stir, and I don't really understand why, but I thought it might not be a bad idea to look over the machine, break it down a little bit and look at the physics of the actual machine. Now the machine itself is two components, obviously. It's got this flywheel section here and it's got this section here. So let's have a look at this section here. This section here is basically a spring and a mass. It's a mass spring oscillator. In the same way that a pendulum is an oscillator, this is a mechanical oscillator called a mass spring oscillator. If I were to just do that, then we can see that it's oscillating, it's vibrating, and it's vibrating at a certain frequency. If it weren't for all of the forces acting on it, and in this case we've got things like, the internal resistance of the spring, we've got the air around it because you're using a flat blade, then it's actually got something on it stopping it oscillating. In that case it's known as a damped oscillator because there is damping on all real world oscillators, and so that period of oscillation, the vibration, well, it stops. And it's gonna stop because it's damped, and so it's a damped oscillator. And that's what we're looking at here. We're looking at a simple harmonic oscillator that is being damped by the natural forces around it that will dampen anything at all. Now there is another component, of course, and that's this bit here. This bit here is just a flywheel. A sewing machine is a good example of a flywheel. It's got a big wheel, a small wheel, joined by a rope, and a foot pedal. You press the foot pedal, the big wheel drives a small wheel acting as a pulley, and when you stop, the big wheel continues to rotate because it has inertia. A flywheel represents a store of energy. When I spin that, I'm putting energy into the flywheel, which is then storing it and giving that energy back out as rotation. It too is subject to the real world, so if I put energy in there and spin it, given that it's on bearings with friction, it's going to spin for a while, but it's going to stop spinning. Of course it's going to stop spinning because it is in the real world. And so we've got these two components. We've got a damped spring oscillator and we've got a flywheel, and we've put the two together because, as I said, we were looking at this idea of components being a tank circuit creating an oscillation. And why would you bother to do that? Well, harmonic oscillation is a really efficient way of transferring energy. Just think of a child on a swing, or think about a bridge waving in the wind. That energy transfer can be incredibly efficient using a harmonic system rather than a direct drive system. And that's, if you like, one of the points of this. So looking at these separately, that's a damped oscillator, that's a flywheel, but of course we've got them coupled right here and we're spinning the flywheel, so this actually becomes what's called a driven oscillator. And driven oscillators have some very interesting properties if we move them at the same time, or if you like, we get the frequency right, because if the frequency is right, then these two become coupled in their motion all of their own. And that is very cool. As they move together, it all presents an incredibly efficient way of transferring energy between one system and another system. We've already seen that when we looked at the Chinese bridge we looked at earlier, and the Tacoma Narrows bridge that collapsed, and the Millennium Bridge that they had to close. So in this system at the moment, this, which is a magnet, plays no role at all. It doesn't matter if it's above, doesn't matter if it's below, but it plays no real role apart from being the weight part of a mass spring oscillator. So just the weight. Now of course I'm thinking later of doing something else with it, which is why it's magnets, but the magnets play no role in explaining how this machine works. Now the point of it is, when you get the frequency right, then the transfer of energy is very efficient, and that's very interesting. So when we look at something like this and what uses an oscillator can have, well, damped oscillators are all over the place. One place you'll see them actually is in car suspensions, and of course we're driving the oscillator using the flywheel, but could we drive the flywheel using the oscillator? Well, of course the answer is yes, we can do that. So if we reversed this machine equally, we could do something with mass damped springs like in a suspension system and use that to drive a rotation for generation directly from mass damping in, say, for instance, a car. So it represents an alternative to a Kerr's system. A Kerr's system obviously uses a flywheel, but here we'd be using the oscillation in the suspension spring to recover energy of the car bouncing up and down. That equally is going to be of interest. So there are lots of interesting things about a simple machine like this, but it's far from being a free energy machine. It is just a driven, damped mass spring oscillator with a flywheel, and it's going to be, well, subject to all of the rules that any machine in the real world is subject to. So the idea of it being a free energy machine seems to have entered people's heads, and I don't know why really that people would do that. The only explanation I can come up with is that people are seeing something different to what I'm showing. I'm showing an oscillation circuit, which is normally seen as a tank circuit or an LC circuit in electronics. To see a mechanical oscillator, then you're looking at things like pendulums and you're looking at things like mass springs. They are mechanical oscillators. So we've created a mechanical oscillator, which is not that difficult to do, to be honest. Coupled it with a force, which is not that difficult to do, and thinking about how we might use that machine in a practical example. And it can be used in one of two ways. We can either get a rotation and have it oscillate and use that to generate, or we can have an oscillation and use that to drive a flywheel and generate from that. Those are my interests in it, and that's why I did this machine. Anyway, I hope that makes it all a bit clearer and more obvious about what I was up to when I was doing this machine. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.